Welcome to the next lecture of the DAR, Design Analysis and Algorithm. Basically, this is our first lecture into the subject. As in the previous lecture, we have just taken the overview of the subject or topics, what we are going to study in this subject. So let's see what we will study in this lecture. Today, we will talk about algorithm. Yes, this lesson is dedicated to the introduction of the algorithm. So before we analyze the algorithm, we must know what are algorithms. So let me show you. The algorithm is named after the person Abu Zafar Muhammad bin Musa al-Khwarizmi. So he was the person behind this name. The algorithm name was given. Now let's give you the definition of the algorithm. What we mean by the algorithm. So let's talk about this definition. A finite set of instructions. So this is an important thing. We are talking about a finite set of instructions that specify a sequence of operations. So the another important thing is that specify a sequence of operations to be carried out in order to solve a specific problem, or to solve a specific problem class. Basically, we are talking about solving a problem is called an algorithm. So by summing up, we can see that we need algorithms to solve a specific problem, and that algorithm is a finite set of instructions. These instructions must be in a proper sequence and must carry out some output. So this is what we mean by the algorithm. The algorithm is a finite set of instructions that specify a sequence of operations to be carried out in order to solve a specific problem. This is the algorithm. So we will be able to understand more about the algorithm. Let's talk about what are the properties of the algorithm. So let's see, these are the 5 properties of the algorithm. The first property is about finiteness. Yes, we had already talked about this finiteness into the definition of the algorithm, that this should be a finite set of instructions. That means the number of instructions that are given into the algorithm must be finite. Let's say in 5 statements we complete our algorithm, in 10, in 100 or any number, but it should be finite number of statements. The next property is absence of ambiguity in each statement. That means each statement must specify what it is doing. There must be no ambiguity. For example, if you write a statement, prepare a cup of tea. So this is not a complete statement or not a proper statement that anybody can understand, especially the machines. So there must not be any ambiguity. So the ambiguity must be absent in each statement, and each statement must be very clearly defined that what is to be done here. The next property is definition of sequence. That means whatever the instructions we are given, there must be a proper sequence of the instructions. For example, we need to take input first, then we need to process, and then we need to provide the output. So there must be a definite sequence. What? The input has to be taken first, then process has to be done, and then output to be displayed. So this is a proper and definite sequence of instructions. So this proper definite instructions of the sequence must be there into the algorithm. The next property is input and output. Every algorithm must have input as well as output. The input can be 0 or more, but output has to be 1 or more, because we have seen into the definition that in order to be carried out, in order to solve a specific problem, that means after the algorithm we must have a solution as output. So there must be a solution as output. So every algorithm must have some input as well as output. The input can be 0 or more, and output can be 1 or more. Next property is about feasibility, that each statement in itself is feasible. It's not like that we write any XYZ statement that cannot be executed, that cannot be understood, that cannot be performed. If we have written a statement that should be capable of executed, that should be capable of implementing. That's we talk about the feasibility of each statement. So these were the 5 major properties of the algorithm. From these 5 properties, we can see the characteristics are very much similar. So properties and characteristics are very much similar to each other. What we mean by characteristics, that each algorithm must possess. The characteristic, mean by the characteristics that each algorithm must possess. So what are these 5 things? Input. Each algorithm must possess input, 0 or more inputs. Second, output. Each algorithm must possess output. It must give output, 1 or more output. The third characteristics, that is definiteness. That means we need to define each and every statement. It is very much similar to, let's say, the absence of ambiguity. We can relate this to the absence of ambiguity. That means each operation must be defined very precisely at what is to be done in this statement. Next is the effectiveness, that each statement must be effective. It should provide some output, it should provide some result, it should provide some result that can be fed it to the next instruction of the algorithm. That is the effectiveness. And in the last, termination. So we can relate this termination with the finiteness property of the algorithm. That means the algorithm must terminate after the execution of a finite number of sequence. It must terminate. It should not go into the infinite number of steps. So this is the 5th characteristics of the algorithm. So these are the 5 major characteristics of the algorithm. Now let's talk about a little bit more about algorithm versus program. What is the difference between algorithm and program? Let's say why we use algorithm. We use algorithm to solve some problems. So that means algorithm will give us the solution to a problem, and we know that there are many solutions. There can be many solutions to one problem. So let's say for one problem we can have many solutions. That means we can have multiple algorithms to solve one problem. So we can have algorithm 1, we can have algorithm 2, we can have algorithm 3. So we can have multiple solutions to a problem. Let's say the problem of searching. As we all know that if you want to search an element from a series of elements, then we have 2 very common solutions. We can use the linear search and we can use the binary search. So we see that the problem was searching, we have multiple solutions. So algorithm 1, linear search; algorithm 2, binary search; algorithm 3, interpolation search. So we have different types of searches algorithms. Now each algorithm, let's talk about, if we have binary search, then we all know that the binary search can be implemented in many ways. A binary search program can be created in many ways. Let's say, so this algorithm can be implemented with different programs. Let's say program 1, okay, let me write it. Let's say program 1, then we have program 2, then we have program 3. That means for even one algorithm we can have multiple programs. So let's say binary search, if we are talking about binary search, then we can implement the binary search using simple conditional and looping statements. If we use the binary search, we can implement the binary search with the help of the recursion, and we can also implement the binary search with the help of data structures. So we have, let's say, array list, or we have collections, or we can use different data structures. So just to implement one algorithm, we have multiple ways of writing programs. So this is the one thing, that a problem can have multiple algorithms, and each algorithm can be implemented with the help of multiple programs. Now, what is the major difference between algorithm and program? 1. Algorithm is a concept. Yes, algorithm is a concept, and program is the implementation of that concept. Right? Searching. How we can search? With the help of binary algorithm, and how the binary algorithm will be implemented with the help of the conditional and looping statements. So algorithm is a concept, and program is implementation. Next difference is algorithm can be infinitely algorithm, it's wrong. It's algorithm has to be finite. We have already seen this into this particular properties. Algorithm has to be finite and a program can be infinite. So the algorithm must have finite number of statements to be executed, but a program can run till infinite number of times. Depending upon, sometimes it happens due to the user input also, a program can go into the infinite. It can happen depending upon while we are implementing the loops and the condition inside the loop that is dependent on the user, then it can go to infinite number of times. So the program can go to infinite number of times, but algorithm has to be finite. So that this is the importance of the algorithm. And let's say we will talk about into the next lecture that why we need to study the algorithms, what are the approaches we can implement for the algorithms, and how we study the algorithms. So these are the three things we are going to study into our next lecture. And in today's lecture we talked about the algorithm, we talked about properties, characteristics, and the difference between algorithm and program. I hope you have understood the concept. Feel free to ask your questions, use the comment box to ask your questions, and that's it for the lecture. Thank you so much.